Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video, we are going to talk about conduction and convection. Both of these processes are used to transfer heat in a substance. Conduction works in solids, liquid, as well as vapor phases of a substance, whereas convection only works in fluids, which are gases and liquids. First, let us discuss conduction. Let us say that here is a spoon. Of course, this is a pen, but let's imagine it's a spoon, and you put that spoon into a boiling pot of water. You're preparing coffee or something like that. Water is at 100 degrees Celsius. You put spoon, first you don't feel anything. But then jiggling of molecules of water that are boiling is transferred to that metal spoon. And then molecules in the spoon, in that metal, start jiggling. And they transfer their jiggling to the part of the spoon between water and your fingers. And then that part, middle part of the spoon, start jiggling. And then that is transferred towards the end of the spoon where you're holding it, and you start feeling increase of temperature. You start feeling transfer of heat. Eventually, if you don't let go, you will burn your skin. But why will you burn your skin? Well, because jiggling in that metal spoon is further transferred into your fingers. And then your molecules of cells that are making up your fingers start jiggling. And at some point, that level of jiggling exceeds structural stability of these bonds in cells, and you would say, I burn my finger. You feel pain. That's because the laws of physics do not care about your pain. There is only thermal conduction of heat. Now, some substances are very good conductors of heat in this way. Some substances are very poor conductors of heat. Here I have a table, and this table has in the left column substance, in the right column thermal conductivity coefficient, which quantifies how good a material is at conducting heat. And we have calm air at 20 degrees Celsius. This coefficient tends to depend a little bit on temperature, so I had to specify here temperature. Calm air at 20 degrees is 0.023 watts per meter per Kelvin, and we know from previous video that watt is unit of power, joule per second. And you can see how thermal conductivity of air is very, very poor compared to some other substances. I purposely put here wood and ceramic, because you know, if you have wooden floor and you wake up in the middle of the night and you start walking, you don't feel cold when you are walking on the wooden floor, but if you have some ceramic, you feel very cold. And your mother would often tell you, don't walk on ceramic bare feet, it's colder. She is wrong. Both wooden floor and ceramic floor or some metal floor are at the same temperature, room temperature, whatever it is. But ceramic or various metals, they have very high thermal conductivity. So your body sits at a temperature of 36, 37 degrees Celsius. And when you step on that floor, if it is wood, it has very poor thermal conductivity, so it doesn't take that much of your jiggling, so to speak. Whereas ceramic or metals, whoa boy, they have very high thermal conductivity. So they drain energy out of you to thermal conduction. Now your mother is right. If you keep standing on that floor, you might catch a cold because ceramic or metal floor will cool you down much faster than wooden floor because thermal conductivity of that floor is very, very high. So conclusion is both floors are at the same temperature, but because there is difference between your body's temperature and those two types of floors, the one that has high thermal conductivity, ceramic floor, will drain your energy or rather heat of your body much, much faster. Now let us discuss this concept further, but also related to convection. Convection is, as I said, mean of transferring heat in fluids, gases, and liquids. Let us say that here we have some hot air, and somewhere here we have big environment of cold air. First of all, we need to know what is hot, what is cold. Hot means hotter compared to this, so it's a relative measure. Cold means colder air compared to this air. Imagine I start having wind, motion, from left to right. That means hot air will go into the region of cold air, which means subsequently temperature of this volume over here will increase, because we would say there is advection of hot air. Now, let us distinguish labeling between atmospheric sciences and engineering. Very important. In engineering and overall in physics, they call convection any sort of transfer of heat. It could be horizontal, diagonal, or it could be vertical. In atmospheric sciences, this transfer of heat by moving fluid is called advection if it is in horizontal direction. Any horizontal direction, this transfer of heat is called advection. Wind is advecting temperature, for example, field. If it is in vertical direction, then we call it convection. So convection would be associated with formation of clouds. Whereas in engineering and physics, they call all of these convection. So just to know that it's the same thing, is just a little bit screwed up labeling between these two disciplines. So let us now further discuss convection and conduction from the first part of this video. Here we have a beautiful surface of our Earth. Here we have even more beautiful sun. Sun is heating up this surface. Let me make a break here because I will use this part of the figure, but this is sun's ray. And of course, this is not to scale. Let us say that we have two different surfaces over here. Surface number 1 indicated with this type of pattern, and let's say surface number 2 indicated with this pattern. Same amount of solar energy falls on both surfaces. Let us say that this one gets warmer and this one gets colder. Of course, you should now ask, how does this one get warmer than that one if the same amount of energy is falling on both surfaces? From my previous video, you know that different substances have different thermal capacity. If this one has a lower thermal capacity, it will heat up faster. Perhaps this is water that takes a lot of energy to change temperature for just few degrees Celsius, and maybe this is land, soil, with lower heat capacity. So differences in heat capacities can result in differences in temperature. Well, that means, as I just said, molecules in this soil are jiggling more than molecules over here. Let us represent that like this. This is jiggling. And here we have just a little bit of jiggling. These molecules of the soil transfer their jiggling, just like in the case of the spoon, transfer their jiggling to the molecules of air through the process of thermal conduction. Thermal conduction has to happen close to the surface because convection cannot occur in the solid surface. So we have to have conduction. But here we have less jiggling. More jiggle, less jiggle. From this point on, convection takes over. This air jiggles more, it has higher temperature. From my previous lectures, we know now that means it has a lower density than this air. So consequently, it will start rising. And we will have a bubble, which we call a thermal bubble of hot air that is rising, and then subsequently we have falling of colder air that is displaced around this bubble to the ground. This process of heat transfer, hot air from the surface is raising up, is called convection. So this over here was conduction. And now here is convection. Convection is much more efficient method of transferring heat in the atmosphere compared to conduction, because as we saw in that table, air is very poor conductor of heat. Nevertheless, keep in mind, please, that conduction had to occur close to the surface. Let us discuss further convection and conclude this video. There are two types of convection. There is something that we call free convection, and there is forced convection. Again, let's take this to be surface of the Earth. As always, I am indicating with Z, height. If we have just what I described in the previous slide, we have this bubble breaking up. So this is at time t0, and then this bubble breaks up here at time t1, and then as it is rising, it is growing t2, at time t2. So there was this convection in the vertical direction, and this is called free convection, because the only thing that initiated it is hot surface, perhaps due to solar radiation heating it up, and then this bubble detached from the surface and started rising. That is called free convection. Let us see how we can have forced convection. Here is the surface of the Earth. Again, height is vertically up, which means we have a mountain over here. Imagine we have a parcel of air that is traveling towards the mountain. Perhaps it is warm. As we will learn later in this playlist, it doesn't have to be warm for the following to happen, but let's just keep everything with respect to this lecture. Let's assume it's warm and it is following in the horizontal direction. So that would be advection, because hot air is moving horizontally, advection. But it cannot go through the mountain, so it starts rising across this mountain. Well, now it is going in the vertical direction. And here we might have, therefore, formation of clouds. And this is called forced convection. Why is this one forced and this one free? Well, this one is forced because if there was no mountain, perhaps this parcel of air wouldn't rise. There is another type of forced convection which is very important, as we will study it in great lengths in the next part of this playlist. If this is Earth's surface, but there is no mountain, again this is height, but let us assume now we have, oops, sorry about this, we have cold air, so this would be cold air, and here we have warm air. Cold air, as we learned earlier in this playlist, is denser than warm air. So if this warm air is moving in this direction, it has to go along this line, this zone that is separating cold air and warm air. We will call this atmospheric front, as you will see. But this is also forced convection, because this warm air would continue going horizontally if it wasn't for this cold air. But because cold air is warmer, this has to go up against it, and again we might have clouds here, resulting in the forced convection. Another example of forced convection, and I will conclude with this, is if we have, again, surface of the Earth, and let's just say somewhere here we have a nice home, perhaps a home where you are watching this video, and there is wind blowing in this direction, and here it has to go around this house of yours, and this creates turbulence. Now, these turbulent eddies, we call those eddies, that are transferring heat in the vertical as well as in the upward as well as downward directions, namely vertical direction, are also called forced convection. So turbulence associated with wind passing over some irregularities on the surface is also causing forced convection. All these will be discussed even in greater details in the rest of this playlist. This type of flow is known as turbulent, and turbulence is quite often in the atmosphere. This was a video on conduction and convection and various forms of convection, in the atmosphere. In the next video, we are going to talk about radiation, which is the third way of transferring heat. Make sure you like and subscribe, please leave a comment and share this video with your friends and enemies. Until next video, goodbye.